In this video, we're going to take a look at specific examples of hybridization for electron domain geometries that are linear, trigonal planar, and tetrahedral. So we're looking specifically at sp, sp2, and sp3 hybridization. So let's start with linear and sp hybridization. A really great example here to show you is BeH2. So if we take a look at its Lewis structure, it's beryllium singly bonded to two hydrogens, and there are no lone pairs of electrons around beryllium. So beryllium is kind of weird because it's satisfied with just 4 valence electrons surrounding it instead of our typical 8 that we would see. So when we look at beryllium, if we were to do its electron configuration or sort of a condensed orbital diagram here, we would have helium, and then we have 2 electrons in a 2s orbital. Okay, and then I'm just going to draw the 3 p's here just so that we can see that they are empty. But we're saying beryllium forms 2 bonds, and we know that bonding has to occur when we have a single unpaired electron in an orbital. So in order to make this so, and to make this the case, we have to take 2 orbitals and mix them together to form hybrid orbitals, each containing 1 electron, so that we can form these 2 bonds. So we always will start with S, and then we'll hybridize to one of the 2p orbitals. So that means beryllium is going to have 2 hybrid orbitals, and because we're taking 1s and 1p, they're called sp hybrid orbitals. And we're taking then the 2 electrons in the 2s, and we're putting 1 in each of the 2 hybrid orbitals. Now, we didn't hybridize these other 2p orbitals, so I'm just going to leave them off to the side here. So these are unhybridized. All right, so we would say that beryllium, or a linear geometry, is going to create 2 sp hybrid orbitals. And those are the ones that will overlap with other atomic orbitals to form bonds. And we would say that then it has 2 unhybridized p orbitals. Okay, so that one's pretty easy. Let's move on to the next shape, trigonal planar. So anything with a trigonal planar shape has sp2 hybridization. Boron's a really great example here. So looking at BF3, boron has 6 valence electrons around it. Again, it doesn't, go with the octet rule, and it's quite okay with that. Now, if we look at boron has helium, and then we'll just draw the 2s, which has 2 electrons, and then in the 2p orbitals, we have 1 electron. Okay. Now, we know from our Lewis diagram, boron forms 3 bonds. We can also tell that because we have 2 electrons here and 1 electron here. So we need to form 3 new hybrid orbitals so that we can have 1 unpaired electron in each. So to do that, we're going to take and hybridize 1 of the s's and 2 of the p's to create 3 new hybrid orbitals. So if we go down here and take a look at this diagram, we're creating 3 new orbitals. And because we're taking an s, they're called s. And we're taking 2 p's, so they're called p2. So they are sp2 hybrid orbitals. And now we can have 3 equal orbitals that all have 1 electron in each. And we didn't do anything with this last orbital here, so we have one of our p orbitals left over. Okay, so we would say that we have 3 sp2 hybrid orbitals, and we have 1 unhybridized orbital. Okay, there we go. Just want to get that in there so that we can look at perhaps one more example on this page here. Actually, let's just erase that so I have a bit of room. Okay. The other shape for trigonal planar is our bent or our V shape. The other shape we have is our bent or our V shape. So a good example is the nitrogen dioxide ion. Whoop, hold on. Let's maybe not draw that one there because we need to get the oxygen in there. And so it has a nitrogen doubly bonded to one oxygen, singly bonded to another oxygen, and a lone pair of electrons on the nitrogen. If we're to take a look at sort of a condensed orbital diagram here, we have 2 electrons and 2s for nitrogen, and then 1 each in the 2p's. So these are all 2p's. Now we can see this shape is based on 3 bonds, so we're still going to create our 3 sp2 hybridized orbitals. But in this case, we're taking this one, and this one, and we have 4 electrons there that we need to spread out. So one's going to have 2, and the other 2 are going to have 1. So the bonding is happening for these singly unpaired electrons, and then our lone pair of electrons are sitting here. So this is our lone pair of electrons. It's still sitting in a hybrid orbital, even though it's not bonding. So a little bit trickier to kind of explain there, but that's what it is. And then we have 1 electron left in our 2p orbital. All right. Now this 1 electron that's left in the 2p orbital, in another video, we're kind of going to take a look at how double bonds are formed. And so that is part of the double bond process. And it's a bit more complicated in terms of its structure here, but we are not going to go into that detail here. Okay, let's move on to the 4 electron domain geometries. So we've got for a tetrahedral shape, sp3 hybridization. So let's quickly look at 3 examples here. We're going to look at methane, which is CH4, and that is a tetrahedral shape. So if we take a look at carbon, carbon has 2 electrons and a 2s, and then we've got our 2p's here, and we have 2 electrons here. Okay, so 4 electrons, we need to create 4 hybrid orbitals. So we're going to take a 2s, and we're going to take all 3 2p's, and we're going to create 4 new hybrid orbitals. And because we're taking an s, it's called s, and we're taking all 3, so it's called all 3 p's, so it's called sp3 hybrid orbitals. And we're combining 4 orbitals, so we make 4 sp3 hybrid orbitals, one with an unpaired electron in each, which means we can now form 4 bonds. So there are 4 hybrid orbitals here, no unhybridized orbitals. All right. The next shape is our trigonal pyramidal. So that's good example is NH3, which has 3 bonds to hydrogens and then a lone pair of electrons on the nitrogen. If we do the nitrogen here, we've got 2s, 2 electrons, and then the 2p, 2p, 2p. And we have 3 electrons here. So again, we are still combining all of these orbitals. So we're going to take the 2s and combine it with the 3 2p orbitals to form 4 new hybrid orbitals that are all called sp3. And we need to distribute these 5 electrons in these 4 new orbitals. So we're going to have 2 in one and then 1 each in the others. So the bonds are being formed by these singly or unpaired electrons in sp3 hybrid orbitals. And your lone pair of electrons here is this pair of electrons sitting in the last sp3 hybrid orbital. We can make the same argument with water. So water has a bent shape, has 2 unpaired electrons here. Now, if we take a look, oxygen is 2s2 and then 2p4. And just for sake of simplicity here, I'm just going to draw our 4 sp3 hybrid orbitals. And we have 6 electrons we need to distribute. So we've got 1 in each. And then we've got 2 that are paired up. So our 2 lone pairs of electrons are here. And then our ones that are forming bonds with the hydrogens are here. So that is sp, sp2, and sp3 hybridization and examples to explain how all of the different shapes contribute to hybridization. That's it then for this video. We'll see you in the next one.